Hello students, welcome to LearnGuru Classes. So today we are going to discuss about remainder theorem. So before starting with remainder theorem, let's see what division is all about. Let's try to have a basic idea about division. Okay, so division has four parts. Okay, one is dividend, then comes divisor, then comes quotient, and then comes remainder. Last of all, remainder. Now, what is remainder? What is remainder that we are going to see? Okay, so suppose three babies are there. Okay, three babies are there, and you are to distribute 7 chocolates among the 3 babies. Okay, so you are to distribute 7 chocolates among the 3 babies. So what do you do? 1, 2, 3, okay, 4, 5, 6, and you are left with 1 chocolate. Okay, so 2 chocolates each baby gets. Okay, and you are left with 1 chocolate. Okay, so let's try to analyze this with the help of the division rule. Okay, so for that 3 babies are there and 7 chocolates are there. So 7 divided by 3. Okay, so 7 chocolates becomes the dividend, and you are dividing the 7 chocolates among how many babies? 3 babies. Okay, so 3 becomes the divisor. Okay, now let's perform the simple division rule to see how it looks like. So 7 divided by 3, that is 3, 7. So 3, 2 just 6, 1. So 2 is the quotient over here, and 1 is the remainder over here. Okay, so remainder means the remaining part. Means you are distributing 7 chocolates among 3 babies. Okay, so each baby gets 2 chocolates, 2, 1, 2, 3, 4, 5, 6. Okay, and you are left with 1 chocolate. So that is the significance of the remainder. Okay, so to understand the concept of remainder, it is very necessary to understand the concept of remainder, or else how will you study the remainder theorem? Okay, so I hope the concept of normal division is clear to you. Let's proceed on with the remainder theorem. So this is the remainder theorem, where let Px be a polynomial of degree 1 or more and let alpha be any real number. So if Px is divided by x minus alpha, then the remainder is P alpha. Okay, so basically Px is a polynomial. Okay, means Px is the dividend. Okay, so what will be the degree of Px? The degree of Px can be either equal to 1 or more than 1. Okay, so degree of polynomial of Px will be greater than or equal to 1. Okay, now Gx. So what you do? Gx be the, this is the dividend. Gx is the divisor. Gx be the divisor. Okay. Now, Gx, the degree of Gx should be equal to 1. Okay. So, it is valid. Remainder theorem is valid for Gx having degree 1. Okay. So, degree 1, let us consider that the polynomial expression for Gx is Gx equal to x minus alpha. Okay, so now if Px is divided by x minus alpha, so if Px by Gx, that is, if we divide Px by x minus alpha, then the remainder is P alpha. Okay, means suppose if px is suppose x cube plus x square plus 3x plus 2 is px. Okay, so gx is suppose x minus 2. Gx is x minus 2. Okay, now simply if I write gx equal to 0, so you are getting x equal to 2. Okay, now p2 will be, you will just replace p2 with 2 cube plus 2 square plus 3 into 2 plus 2. So it will give you a value as 8 plus 4 plus 6 plus 2. So 8 plus 4 is 12 plus 6 is 18, 20. Okay, so x minus 2, that is x equal to 2. So p2 you are getting as 20. So when you divide px by gx, it will give you the remainder as 20. So this is the remainder theorem. Means px is any polynomial of any degree, okay, greater than or equal to 1. Okay, and gx is a polynomial which has a degree equal to 1. Okay, so suppose x minus alpha. Okay, so when you divide px by gx, that is x minus alpha, okay, so the remainder will be p alpha. So px by gx, okay, so x minus 2, so you are replacing px with p2, so p2 is the remainder. Okay, so first of all, let us try to understand the proof of the remainder theorem. After that, we will solve one example related to remainder theorem. Okay, so let's see. So the proof is, let px be a polynomial. Let px be a polynomial and of degree greater than or equal to 1. Just I have written like this. Okay, gx be a polynomial, okay, of degree 1. Okay, so let us consider gx equal to x minus alpha. So it has a remainder of, it has a degree of 1. So when px divided by gx, when we divide px by gx, we get qx as quotient and rx as remainder. Okay. Now, in the division algorithm of polynomials, it was given to you that the degree of Rx should be less than the degree of Gx. Okay, so already degree of Gx is equal to 1. So degree of Rx should be less than 1. That is, less than 1 means what? It should be 0, isn't it? Either it should be 1, it cannot be fraction. Within 0 and 1, okay, no positive exponents are there. Only the thing is that it cannot be a fraction according to the condition for the polynomial. So it should be 0. So the degree of Rx should be equal to 0. So the degree less than 1, that is degree of Rx, that is degree of Rx should be equal to 0. So degree Rx equal to 0, that is Rx is a constant. Suppose 5 is a constant. So 5, we can write 5 into x to the power of 0, right? So x to the power of 0. So the degree of this is 0. 5x to the power of 0, degree is 0. That is 5 is a constant. So R, that is R or remainder, is a constant. Remainder is a constant. Okay, remainder is a constant. Okay, up to this I think it is clear to you. Okay, now let's proceed. Let us rub this. Okay. Okay, and we will keep only the Rx as a constant. This part we will keep. Okay, now according to division algorithm, what is given to you? Px is equal to Qx into Gx plus of Rx. Okay, yes, this where Qx is the quotient, where Gx is the divisor and Rx is the remainder. Okay, so it's given that x minus alpha equal to Gx. Okay, now if Gx equal to 0, so we can write that x minus alpha equal to 0, that is x equal to alpha. X equal to alpha. So let's keep this as equation 1. So from equation 1, we can write P, just replace x with alpha. So you are getting alpha. Okay. This we will take one step further, that is Qgx, we can write it as Qx into x minus alpha plus of Rx and give this as equation 1. So from equation 1, Qx will, let us take it as Q alpha into x minus alpha. X minus alpha is what? X minus alpha, alpha minus alpha is 0 and this is plus of R. So Rx, let us take the R is a constant. So R. So you are getting P alpha equal to 0 plus of R, that is R equal to P alpha. So P alpha is a constant, R is also a constant. So here the division algorithm or the remainder theorem is proved over here. Okay, so this is the proof for division remainder theorem. The things will be more clear to you when I will take one example and try to solve it. So this is the example. Find the remainder theorem when the polynomial px equal to x to the power of 4 plus twice x cube minus 3x square plus x minus 1 is divided by gx equal to x minus 2. So here you are to apply remainder theorem to find the remainder Rx. Okay, so Px given, Px is x to the power of 4 plus 2x cube minus 3x square plus x minus 1. Gx is x minus 2. Okay, so according to remainder theorem, is Gx equal to x minus 2, that is Gx has a degree of what? Degree of 1. So if I do Gx equal to 0, so you are getting x minus 2 equal to 0. So that is x equal to 2 you are getting. So you are to put the value of x in this expression. So Px is x cube, x to the power of 4 plus 2x cube minus 3x square plus x minus 1. So this will become as P2. Means you are going to replace x with 2. So this will become 2 to the power of 4 plus 2 into 2 cube minus 3 into 2 square plus 2 minus 1. So this becomes 16. 2 to the power of 4 is 16 plus 2 into 2 cube is 16 minus 3 into 2 square, that is 12, plus 2 minus 1, that is 1. So 32 minus of 12 plus 1. So 32 minus 12, that is 20. 20 plus 1, that is 21 is the answer for this. So the remainder is 21 according to the remainder theorem. Now this you have found out the theorem without actually performing the division, without actually finding the quotient remainder, just you have found out the remainder from this. So to verify this, let us use the long division method just for your understanding. Okay, I will try to use the long division method to prove you whether remainder exactly comes out to be 21 or not. Okay, so let's do the long division method. Long division method. So px equal to px is this, gx is this. So x minus 2, x to the power of 4 plus 2x cube minus 3x square plus x minus 1. Okay, so this is long division method. Now x minus 2. So what will you multiply so that it will become x to the power of 4? You will be multiplying it with x cube. So this is x to the power of 4 minus 2 x cube. So this will become, here you will write it as x cube. So x to the power of 4 minus 2 x cube. Okay, so this becomes as minus. So this becomes 0 plus minus minus plus. So this becomes 4x cube minus, again we take it as minus 3x squared. Now what will you multiply with x minus 2 so that it becomes 4x cube? So what will you do? X minus 2 into 4x squared. So this will become 4x cube minus 8x squared. So this becomes 4x squared. So this is 4x cube minus 8x squared. Okay. So this becomes minus, minus gets cancelled, minus minus plus 5x squared plus of x. Okay. So again you will be multiplying x minus 2 into 5x. So you will be getting 5x squared minus 10x. So this becomes as plus 5x. So this becomes 5x squared minus 10x. Okay. So this is minus, minus this becomes 0, minus minus plus, that is 11x. So 11x minus 1. Okay. Now you will be multiplying x minus 2 with 11. So this is becomes 11x minus 22. So this becomes 11. So 11x minus 22. Here this is minus, minus minus gets cancelled. 11x gets cancelled. Minus minus plus 22. So 20 plus 22 minus 1. That is you are getting as 21 as the remainder. Okay, so here also you are getting 21 as the remainder. Here with long division method also you are getting with 21, isn't it? So this is the beauty, or this is the necessity of remainder theorem. See, the long division method is so tedious, isn't it? But without actually perform, if you have only px, if you know the value of gx, so without going with such a lengthy method, you can find out the remainder. Okay, using remainder theorem. So this is the significance of remainder theorem. Okay, so next class we will be solving some sums related to remainder theorem. So I am ending the class here. If you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and family. So thank you so much. Bye-bye.